Session 2007, second one, exercise number 1. So it's about the mechanical interaction, and we are still in the linear momentum. So the question or the aim of this exercise is to study some physical quantities of system whose parts are in mechanical interaction. So we use two pucks A and B of respective masses. You have 0.1 kilogram and 0.12 kilogram that may move without friction or horizontal table. Each puck is surrounded by an elastic steel shock ring of negligible mass, and the two pucks are connected by massless and inextensible thread, thus compressing the steel shock rings. So these are compressed. These two are compressed. The system S thus forms is at rest. So this is very important. The system S is at rest, and S is the system formed by the two puck A and B. So we burn the thread, the shock rings stretch, and the pucks repel each other. So لما بنجي بنحرق هذا البارت كانوا هودي compressed. شو رح يصير فيهم؟ كل وحدة رح تروح باتجاه. So they will go in two different directions. The system as those forms of the two pucks and the shock rings is said to explode. So this is very important. And now here when we talk about explosion or collision, it's the same thing. So بمجرد ما قال explode أنا براسي لازم أحط إنه أنا عم بشتغل explosion. This means that I can use the conservation of linear momentum. This means P before the explosion is equals to P after the explosion. هيك بنكون نحن عم نقسم أفكارنا قبل ما نبلش بحل السؤال. The position of the center of mass of each puck are registered at successive instants separated by constant tau equal 50 milliseconds. So figure 2 represent we have the figure 2 represent the axis X and the dot prints of the position of the two puck after explosion. So now, before explosion, it's at rest. When we say at rest, this means V of the system is equal to 0. So this means P of the system before the collision, okay, when V is equal to 0, then P of the system is equals to 0 before the collision. Now, we continue. So we have this figure is after collision. Now the question is what? The question is, using the document of figure 2, show that after explosion, the motion of each puck is uniform. So this is part 1A. In order to show that it's uniform, we can look at the figure. And we know that the distances, if we see here, the distances between the two dots are equal. So here we have equal distances, and here also we have equal distances. When the distances are equal, and during the same interval of time, then in this case, it's a uniform motion. So here I can say uniform since the distance during the distance covered. This means it's the distance covered, or we can say the displacement, okay? So the distance covered during the same interval of time which is tau, so it's the same interval of time اللي هي نحن معنا إياها tau is, so the distances are equal. This is why it's a uniform motion. And when I say uniform motion, so directly هون between bracket لازم أعرف إنه إذا uniform motion بحط ببالي إنه this means I can use the acceleration is equal to 0, this means V is equal to constant, and this means that X is equal to Vt plus X0. And when I say Vt plus X0, this means the displacement is equal V times T. So D هي displacement, which is X minus X0. So it's equals to V times T. Okay, هود بنحطهم على جنب لنا. Now the speeds of A and B are VA. So it's show that the speed of A and B are VA and VB. So when we now the speed, so simply we have the displacement is equal to V times T. Then here I can find VA, which is the displacement over the interval of time. When I say displacement here, so it's D over delta T. And here the displacement, I took all the part اللي هو رسمنا إياه واللي هو 24. So it's 24, but here it's centimeter. So it will be 0.24 meter. And over, and we see how many tau. So we have 1, 2, 3, and 4. So it's over 4 tau. Okay. والتاو أكيد بنحولها ل second. So نحن معنا tau it's equals to 50 millisecond. So it will be equal to 50 times 10 to the power minus 3 second. And we substitute. So we will have as answers, وهيطلع معنا here the answer is equals to 1.2 meter per second. This is for VA. Same thing for VB. So VB is equal to D over delta T is the displacement over the interval of time. And here the displacement is 20, so it's equals to 0.2 in meter over, let's see how many tau. So we have 1, 2, 3, and 4 also. So it's over 4 tau, and the answer will be equals to 1 meter per second. These speeds are the speed of A and B after collision. So now verify part 2. It's verify the conservation of linear momentum of the system as during explosion. So here I want to verify it. Now in order to verify it, إذا تتذكر وقلنا what do we do؟ بنعمل summation of F external equals to dP over dt, and then I trace the forces. But هون مش بحاجة نعمل هيك. Why؟ لأنه the question they told us verify after having the values. So in order to verify, I must use these values. This means هون مفروض استعمل okay P before, I have it. P before, it's equal of the system, it's equals to the total mass times the velocity, can it at rest, so it's equal to 0. Now P after the explosion, is equals to P of A plus P of B. And كمان P of A and P of B, what after the explosion. So the answer will be equals to, here we have P of A, it's M of A times VA plus MB times VB, and then I can put the answer, so we'll have is equal to 0.1 times VA واللي هي طلعت معنا it's 1.2, but pay attention, this is 1.2, this is the value, but VA in terms of I am مش vector, so VA is opposite to the x-axis. Opposite to the x-axis, then in terms of vector, it's minus 1.2 I. Vector equal to a vector. Plus MB, so we have MB is equal to 0.12. And time, بطلع على VB after the collision, it's with the x-axis, so it's positive, so it's 1I. Vector. And then at the end, so هيطلع معنا the answer is equals to 0. Here. بما أنه بيطلع عندي the answer is equals to 0, then بوصل لهون P before the collision is 0, P after the collision كمان طلعت معي equal to 0. This means that we have P before is equals to P after, so we have conservation. So it's constant, then it's conserved. So here ليه عملنا الكالكوليشن؟ لأنه we have the velocity after collision. This is why قدرنا نشتغل هذا الشغل. Now part 3, applying a Newton's second law, dP over dt equals summation of F external on each puck, and assuming that the time interval of the explosion is 0.05 second is so small that you can use delta P over delta T. Determine the forces FA on B and FB on A exerted respectively by A on B and by B on A. So here مفروض ننتبه إنه أنا صار بدي FA on B and FB on A. So here we must trace the system. So this is A and this is B, and I will say that this is just at the moment of the collision. So just at the moment of the collision, we have this is the force done by B on A, and this is the force done by A on B. And then I must trace all the forces. So we have the normal A, the weight A. So this is the weight of A and normal A. Also normal B and weight of B. And I will put the x-axis. So ما ننسى the steps of Newton's second law. We put the x-axis, we trace the forces, and then we apply Newton's second law. So as system, now لما بيجي بقول لنا determine the forces FA on B, so it's on B. If it's on B, then I will take as system is B. So system B, then I will say summation of F external on B is equals to dP, or I can use a delta P over delta T. So it's equals to delta P over delta T. Since we have delta T is equals to 0.05 second, this means, so I continue here. So what we have as forces, we have NB, we have weight B, and we also have the force done by A on B. So هون بدنا ننتبه, this force is not internal forces here, it's external. Why? It's done by A on B, and A is not in the system. So it's equals to delta P over delta T. When I say here delta P over delta T, I mean here it's P of B after the collision, so it's after the explosion, sorry, minus P of B before the explosion. Over delta T. And we know that here we are using the motion is along the x-axis. So it's along the x-axis, then normal and weight ما بيهمونا. This means FA on B, so I can say that FA on B vector, it's equals to FB after. When I say FB after the collision, this means M times V. So نحن بنعرف هون, this means M of B times VB after the collision minus M times VB before, بس نحن كنا بنعرف إنه كانوا at rest, then this is equals to 0 here, and over delta T اللي نحن معنا إياه 0.05. So we have كان نحن معنا ال VB, it's equals to 1 meter per second, and in terms of I it's 1I, so صار أحط هون 1I times the mass over 0.05, so حيطلع عنا ال answer it's equal to 0.12 between a bracket times 1I and over 0.05. So FA on B will be equals to 2.4I. And we notice that it's true. كيف يعني it's true? It's positive. FA on B هي it's with the x-axis, it's positive. Now same thing, السؤال شو كان and FB on A. So نفس الشغل هلا بدي اشتغله بس لمين السيستم. So هلا صار السيستم اللي بدي اشتغل عليه هو السيستم A, and I do the same thing. So I will do summation of F external equal to delta P over delta T, which means as forces كمان عنا weight A plus normal A plus force done by B on A, and it's equals to delta P. When I say here delta P, this means P of A after the collision minus P of A but before the collision. And كلها it will be over delta T here. So I can continue the calculation. كمان أنا عم بشتغل on the x-axis. This means so الويت رح يروحوا, so حيطلع weight والnormal ما بدنا إياهم, they are vertical, so it will be FB on A, it's equals to كمان before the collision, so we have A is at rest, so this will be equals to 0. بعنا after the collision, so this is 0 vector. After the collision we have كان طلعت معنا VA, it's equals to minus 1.2I لأنه it's opposite to the x-axis, so we'll have 0.1, it's M times minus 1.2I over 0.05, and the answer will be equal to minus 2.4I. بهيك نتأكد إنه جوابنا صح. We must have here and here same value but opposite direction, and this will be the question number 5, number B, part B. The part B, verify the principle of interaction. So here, in order to verify the principle of interaction, simply I can say we have FA on B is equals, so FA on B vector is equals to minus FB on A. Okay, so this is verified. هيك بنكون بايعنا the principle of interaction. Now the last part, the system S possesses a certain energy before the explosion. Specify the part of S storing this energy. So قبل الإكسبلوجن كان في عنا حدا عم بيخزن energy. مين اللي كان عم بيخزن energy? So here it's the ring, it's the elastic ring. Why? Since when I cut or when I burn this elastic ring شو صاير عندي؟ صاير عندي explosion يعني كانت كلها مخزنة وين؟ بقلب هيدي elastic shock ring. In the part B, in what form is this energy stored? Okay, so واضحة in what form? So قلنا it's an elastic, so it's stored in the form of elastic potential energy. Potential energy. It's like example, another example of for example, if we have also elastic energy, ما قد بيكون عنا like this. Okay, we have this is the first object, and this is the second object, and these two are compressed. These two objects are compressed by a spring. Okay, they are compressed by a spring وضاغطينهم يعني واصلين مع بعض. They are fixed. And then شو بنجي بنعمل؟ What do we do? بنجي بنقطش هيدا البارت اللي وصلهم مع بعض. اوكي اللي جمعهم. لما بجي بقطشها لهيدي what will happen? The spring will what? will elongate. رح يطفش هود الاثنين. So كأنه صار عندي كمان explosion. Also here the energy is stored in the form of potential elastic energy. So this is another example. Now in the part C, determine the value of this energy stored. So ما نطلع ال energy stored. نطلع ال energy stored here. What should we do? We should find the mechanical energy of the system. ليه؟ لأنه نحن بنعرف إنه أول شيء mechanical energy of the system here is an isolated system. So mechanical energy رح يطلع عندي it's conserved and there is no friction. So then in this case, what should I say? I should say that ME is equals to KE plus PE, but أنا عم بشتغل هون PE elastic. هلا في أحط plus PEG بس PEG it's equals to 0. So it's equals and we have that this ME, so I will put it plus PEG, but PEG is equal to 0. So this means that ME before is equals to ME after. So ME before is equals to ME after. And then here صايفي يكمل, so it's equals to, this means ME before, شو كان عندي before؟ ما كان عندي speed. Okay, so كانت ال KE يعني إذا بدي أجي أقسمها we have KE plus PEE, PEG قلنا صفر, equals after KE plus PEE. Now before the collision, okay, sorry, before the explosion, كان عندي ال KE كان at rest, so كانت ال KE 0. And PE elastic, we must find it. هيدي نحن بنعرفها, determine the value of this energy. So this is the question, is to find it. Okay? And then equals to KE after. Now after the collision, we must pay attention that we have the system is formed by two objects. So لما أنا عم بقول KE, هون انتبه منيح إنه السيستم اللي أنا عم بشتغل فيه هن اثنين, هن ال A وال B مع بعض. So after the collision, when I say KE, I mean KE of A and B. So شو حيطلع عنا هون؟ حيطلع عنا هون the answer, it's half MA VA square plus half MB VB square, and here plus at the end PE elastic, but PE elastic after the collision هي 0. ليه؟ لأنه after the explosion. لأنه after the explosion نحن أصلا we burned this elastic. So هيدي راحت. So this is plus 0. I have VA and VB after the collision. بأنه نحن معنا VA and VB and we have the masses. So فينا نحط بس الأرقام and the answer will be here equals to 0.132 joules. Okay, so this is for this session.